But what about securing data when it is being actually processed? How to protect the data and the code? So the first question that should come to our mind is what exactly is confidential computing? So how can confidential computing can help in machine learning processing? For example, you might know about card tokenization, right? That nowadays apps like Flipkart, Amazon, Google Pay, Phone Pay, everyone uses. So this tokenization process can happen inside a TE also, okay?
Let's take a look at how major cloud providers like AWS, GCP, Google Cloud and Microsoft Azure implement the TE technology.
Hey everyone, welcome back to the channel. Imagine a vault so secure that even if someone breaks into it, they still can't see anything. Sounds like science fiction, right? Well, in today's digital world, it's not only possible, but it's here. So today we are exploring a powerful security concept called confidential computing. Generally, data on rest or data in transit can be encrypted and protected. But what about when it's actively being used or processed? So today I'm going to take you on a deep dive into this topic. Okay. So protocols like AES, also known as Advanced Encryption Standard, and RSA are widely used to encrypt the data at rest or the storage data. Okay. So AES with its symmetric encryption technique, it is highly efficient for large data volumes, while RSA provides a public key approach which is ideal for securing encryption keys. On the other hand, when data is in transit, that means data is being transferred, right? That means the data is flowing through the internet from your browser to a web server. So TLS or transport-led security is the primary protocol for encrypting data and used for securing HTTP traffic into HTTPS and encrypting connection between web browser and servers and APIs. Okay, so TLS ensures confidentiality and integrity of the data being transmitted. So also protocols like SSH or Secure Cell provide encrypted channels for secure remote access and file transfer. So SSH uses a public key cryptography to authenticate users and establish secure encrypted sessions. But what about securing data when it is being actually processed? Let's say we have a ML server that processes sensitive data and builds models. Okay, how to protect the data and the code? So that's where confidential computing comes into picture, and something called trusted execution environment or TEE come into the picture. So we are going to break down how confidential computing works, dive into the roles of TEEs, and see how this can revolutionize secure data access and code management, and how different type of cloud providers such as AWS, GCP, and Azure are providing support for confidential computing. So let's get started. So the first question that should come to our mind is what exactly is confidential computing? So it's a technology that protects the data during processing by using a secure isolated area inside a CPU called trusted execution environment or TEE. So that secure environment keeps the data encrypted while it is being processed. So even if someone gains the unauthorized access to a system, the data in the TEE would still be secure. Okay. Now let me just change the slide and let's zoom into on how a trusted execution environment or TEE works actually. Okay. So think of TEE as a mini secure area inside the CPU. So this is our processor, this is our CPU, and this is a small area inside the CPU, a secure area. So when data enters this environment, it is encrypted right away, and only specific authorized code has the keys to access it. So this encrypted data remains isolated, which means even the OS or any hypervisor or any other external parties, external application or software or any malicious app also, they cannot access the data that is being processed inside the TEE. So this is where confidential computing truly shines. So let's dig deeper into how TEs handle encryption. Okay. So when data is loaded into a TE, it gets encrypted with a special encryption key. So this key is generated and managed within the TE only, which means it is never exposed outside, right? So only authorized application, as we discussed, running in the TE have the permission to decrypt and process this data. So if any unauthorized access is attempted, even by the system admin even, okay, the data remains fully encrypted. The TE itself is designed to destroy itself and its encryption keys and the data inside it if any tampering is detected. There is one more fascinating layer inside the TE. So TEs can detect and respond to tampering also. So if there is an attack on the TE, like an attempt to extract or modify data by some malicious app or software, the TE will immediately lock down, encrypt, or even destroy the encryption keys as we discussed. So this makes it nearly impossible for any unauthorized users to access sensitive information which is being processed inside the TE, even if they have the physical access to the hardware. So the isolation within the TE is one of the most secure ways to process sensitive data. So how can confidential computing can help in machine learning processing? So ML applications often require sensitive data, right? Like personal information, medical records, or transactional data or financial data to create accurate predictions and build models. But this creates a dilemma actually, right? We want to leverage the data for accuracy, but we also need to protect its privacy. So with confidential computing, an ML model can process sensitive data securely within the TE, where it remains encrypted throughout the training process. So for example, a healthcare provider could train a model on patient data, let's say, knowing that the data remains safe inside the TE. Moreover, confidential computing also supports secure collaborative ML approaches like federated learning, multi-party computation. So let's say banks want to collaborate on a fraud detection model. Okay. So with confidential computing, they can process data within their own TEs, sending only encrypted and anonymized model updates to the central server. So no raw data is ever shared, protecting the privacy while enabling collaboration and data processing, right? For example, you might know about card tokenization, right? That nowadays apps like Flipkart, Amazon, Google Pay, Phone Pay, everyone uses card tokenization, where they tokenize your credit card information. So this tokenization process can happen inside a TE also, okay? So also the de-tokenization process happens inside the TE to retrieve back the actual card information for processing a transaction. We'll create a separate video in details explaining how Flipkart, Amazon processes transactions using card tokenization technique without actually storing your entire card details in the database as it is, right? So in short, this kind of card tokenization process also happens inside a TE, okay? Now let me just change the slide. So now that we understand the basics of confidential computing and how a trusted execution environment or TEE works, let's take a look at how major cloud providers like AWS, GCP, Google Cloud, and Microsoft Azure implement the TEE technology. So each of these cloud providers has developed its own approach to offer secure environments, allowing companies to protect data and code during processing. Okay. So let's start with AWS. So AWS has a solution called AWS Nitro Enclaves, which provides isolated TEs within certain EC2 instances. So with Nitro Enclaves, user can create a highly secure environment on EC2 machine, completely isolated from the instance's operating system. So Nitro Enclaves are designed for data sensitive applications like machine learning, where code and data need to stay private, even if the host instance is accessed, right? So AWS also integrates Nitro Enclaves with AWS Key Management Service like KMS for secure key management and key handling, ensuring that any encryption keys or sensitive data used in an enclave are kept secure and separate from the rest of the EC2 instance. Also, as we discussed, tokenization is a process that converts highly sensitive data such as credit card information, then healthcare data into tokens. So with Nitro Enclaves, customers can run the application that does this conversion inside an enclave with a secured environment. So encrypted data can be sent to the enclave where it is decrypted and then processed. So the parent EC2 instance, which is using the enclave service, it won't be able to view or access the sensitive data throughout this process. So now let's talk about GCP and Azure. Okay. So Google Cloud has its own TE-based solution known as confidential VMs. Okay. So confidential VMs use AMD SEV, that is secured encrypted virtualization technology, which encrypts the memory of the virtual machines while they are being processed. Okay, so this allows users to perform sensitive computations while ensuring that the data remains confidential and encrypted, even in shared environments. So GCP's confidential VMs are designed to protect data from insiders and from unauthorized actors, giving a peace of mind to organizations that need to run sensitive applications on the cloud, right? Now over to Microsoft Azure. We have Azure confidential computing with TEs powered by Intel's SGX technology, that is software guard extension technology. So Azure's confidential computing enables secure enclave creation to isolate the data during computation, just like the other cloud service providers. So Intel SGX provides granular control over the data and code, ensuring it is protected at the hardware level, right? So you can go to the Azure portal and check out their services on this confidential computing. Okay. So Azure also offers confidential virtual machines which work alongside Azure's identity and access management or IAM tool to further secure the data. So with each provider offering these unique TE options, organizations now have more choices for keeping their data secure on the cloud across AWS, GCP or Azure. So confidential computing is not just a concept anymore. It's a practical solution offered by various big players in the cloud service, right? So whether it's Nitro Enclaves on AWS or confidential VMs on Google Cloud or SGX powered enclaves on Azure, these options let you run even the most sensitive application with a peace of mind. So the benefits are clear, right? Confidential computing provides robust privacy, regulatory compliances, and security advantages. by ensuring that the data remains protected even while being processed and blocks any unauthorized access to it. So it opens up a world of possibilities for sectors like finance, healthcare, and even government organization can take advantages of this service to create a more secure infra and architecture, right? And they can do the data analysis of sensitive information without compromising the privacy. So that's about confidential computing, which is an innovative approach to protect the data during processing, all thanks to TE and its encryption mechanisms. So as machine learning and data-driven applications continue to grow, this technology will be a game changer definitely. So if you're excited about confidential computing as I am, don't forget to like this video and subscribe to my channel and share your thoughts about this video, whatever you go to learn in this. So also check out my playlist on system design where we combine system design concepts with real life use cases. Click on the eye icon above to explore the playlist. You can also check out my other playlist, Learn Out of the Box, where we discussed this type of interesting topics like the one today. Okay. So if you got any doubts about whatever we discussed in this video, so you can put them in the comment section and I will be sure to answer them. So targeting to reach 1800 subscribers by the end of this month. So keep supporting. So thanks for watching this video and I will see you in the next one. Thank you.